Hi everyone. So last lesson we looked at the modern periodic table, and in this lesson we're going to be looking at the Mendeleev's older periodic table version. So Mendeleev, you need to know his name. He's the person who came up with the first model of the periodic table, right? It's the founder of the modern periodic table. Now, his periodic table looks slightly different to what we have currently, right? Currently, we have the group numbers very clearly indicated at the top. We've got period at the sides, and we've got also the relative atomic mass and the proton number, atomic number, both written on the periodic table. In the older version, we have the group number, we have the period number, but we don't have any atomic number or any mass number written on the periodic table. The reason for this is atomic number, as we know from previously, is the number of protons. Number of protons. However, protons were only discovered after Mendeleev created this table, right? So when he was creating this table, we did not discover protons at that time. So protons were only discovered later. So for Mendeleev's time, protons did not even, well, they did exist, but they were not discovered at that time. So in Mendeleev's time, remember that protons were not discovered, right? So if the question ever asks, why is it not in order of atomic number? Well, atomic number is protons. They don't even exist, or they weren't even discovered at that time. Okay? Then what he did is he arranged it, therefore, in order of atomic weights. Atomic weights is not mass number, right? That is not the same as mass number, because mass number is the number of protons and neutrons, which weren't discovered at that time. Atomic weight is our relative atomic mass. Relative means a comparative. So they compare the weight of each element and they weigh it from lightest to heaviest. So relative atomic mass, right? That is what the atomic weight is, the relative atomic mass. That's really important that you understand that. Next part. So he kept ordering it in this relative atomic mass, getting heavier and heavier as you go across. Then he wanted to make sure that elements that have very similar properties, and what do I mean by properties is how they react with water, how they react with oxygen, so the way they react, and their physical appearance. So are they a solid? Are they a gas? Those kind of chemical and physical properties, right? He experimented with all the elements that were available at that time, and he placed everything that react in similar ways in the same columns. So this is our column. We don't call it group back then, we call it columns. So elements that reacted very similarly are in the same column. Beryllium, magnesium, calcium, strontium, they all react the same way. We've got oxygen and sulfur, they all react in the same way. So one of the main thing he does, and this is a key sentence, yeah? Make sure you learn this. Elements with similar properties are placed in the same column. So anything he did, it's so that elements with similar properties can be placed in the same column. Whether he reversed the order of some of the elements or whether he left the gap, every single decision he took was to make sure that elements with similar properties are placed in the same column. When we look at exam questions, you would see how common this phrase comes up as an answer, right? So few things they would ask, why did he leave gaps? Right? He left it so that when he does place the elements, place it in the element, you place it in the column with the same similar properties, right? That's why he left these gaps. Back in the days, they hadn't discovered all the elements. So these gaps are for the undiscovered elements. So that, look at the keyword, right? So this will give you 1 mark. So that elements with similar properties can be in the same column, right? That will give you your 2nd mark. And sometimes he found that elements didn't really match the order. The atomic weight wasn't actually going in order, but he didn't prioritize the atomic weight. He still prioritized to place elements with similar properties in the same column. So in some cases, the atomic weight was reversed. They would ask you why. The reason is always the same. Okay? The next part is that scientists only started accepting this model after a few years, right? Scientists accepts the model after a few years. And you need to know why. Reason is when they discovered the elements, it matched exactly in the space that he left. And it also matched the property of the column that he mentioned. So discovered elements fitted the gap in terms of atomic weights, fitted the gap. And it matched his predictions because every time he left a gap, he knows what the column reacts like. So he gave it a prediction. And when they were discovered, the discovered elements matched his predictions in terms of how they react, how they would look like. Right? That's all you need to know about Mendeleev's periodic table. Thank you.